example here where you do have to use integration by parts twice. And that's about as hard as these get. Alright, so repeated integration by parts is a possibility. So here's the example. Say I want to integrate x squared times the sine of 2x dx. First of all, I want to address the fact that I'm sure I have some people that immediately see this and think, I bet I could rewrite that. Might make it easier. And to be honest, I didn't try. So if you want to try, that is a great idea. It's something that I probably would try. I happen to not solve it that way because I just stuck to my integration by parts, but it's something that is not a bad idea. The other thing is that for me, I know that I need to identify a u and a dv to start. And then from that, I need to integrate to get du and find the I need to take the derivative to get du, and I need to take the antiderivative to get v. So I just like to set things up in a little table that looks like this, just 4 little quadrants. You definitely don't have to, just an organizational suggestion. So as I'm looking at this, which one do I want to be u and which one do I want to be dv? Well, I don't know. I'm going to take a guess. Just remember that whatever you pick to be dv has to include the dx. Alright, let's integrate and find the derivative. So here I need to find the derivative, 2x dx. Excuse me. Here I need to find the antiderivative, which will be negative cosine 2x, and then because of the 2 I need to divide by 2 or multiply it by 1/2. Alright, let's try my formula and let's see what we have. So we've got u times v, so that's x squared times negative 1/2 cosine 2x minus the antiderivative of v du, negative 1/2 cosine 2x times 2x dx. That was step 3. Use your formula to plug in what you know. Let's simplify. Not a whole lot that I can do here. Remember that this 2x is inside the argument of cosine, so you can't combine those in any way. But I can write this as negative x squared cosine 2x all over 2, just to make it look a little nicer. And then over here, the 2x here is the argument of cosine, but we have multiplied by another 2x. So those 2's can actually go away, and then I can simplify my signs here. So plus the antiderivative of x times the cosine of 2x dx. Now we're not done until we've actually found this antiderivative. The problem that you're going to run into is that we don't really have any strategies that are helpful here. Substitution isn't a good option. Perhaps using a trig identity, you might be able to get somewhere. But because we're focusing on integration by parts, what I'm going to do is I'm just going to once again repeat that process to illustrate how that's done. So I'm going to repeat integration by parts one more time with this guy. Once again, I need to figure out what's u and what's dv, and then I need to utilize each of those to find the other parts. I don't know if this should be u or if this should be u. I'm just going to guess, and hopefully it works. Okay, so I'm going to let x be my u, which means that dv has to be the cosine of 2x dx. Let's find the derivative and the antiderivative. du is going to be 1 dx, which is actually really helpful. Whenever that happens, you know you're on the right track. The antiderivative of the cosine of 2x is going to be the sine of 2x, but multiplied by 1/2 to adjust for that double angle. Alright, I'm going to need some more paper here, but we're almost done. Alright, so what we have is this first term, which came from our first iteration of integration by parts. And then from this second iteration of integration by parts, I'm going to end up with 2 more terms. So I need my formula once again as it relates to this u and this dv from my second round of integration by parts. So this is u and this is v, which I didn't write. This is v. So I'm going to have x times 1/2 sine of 2x minus the antiderivative of 1/2 sine of 2x dx. Okay, so that's really good news. When I have just a dx, it generally means that this is going to be something that I can integrate. And that means that I don't have to do a third round of integration by parts. Alright, clean things up and integrate. So I'm just going to put the x sine 2x on the top, divide the whole thing by 2 here. On this one, I'm going to take out the constant multiple of 1/2, and I'm going to integrate the sine of x, or I'm sorry, the sine of 2x dx. Okay, we can do that. Sorry, let me move that paper out of the way there. Alright, so the antiderivative of sine of 2x is going to be negative cosine 2x times 1/2 or over 2. Don't forget to multiply it by our constant multiple. And in the end, we've got 3 terms as part of our answer. Well, actually 4, but I'll show you where that comes from in a second. So I've got my first term, which came from u times v in my original integration by parts process. I've got my second term, which is also u times v in my second round of integration by parts. And then my third term is going to be plus the cosine of 2x over 4, with my fourth term being to add c. And there we go. So that's an example of where we would have to repeat the process of integration by parts. Just an idea, back when we were at the point where we decided that we had to use integration by parts a second time, we might have considered going back to the very beginning and switching our u and our dv to see if that is helpful in not having to repeat the integration by parts process. I did try it on this problem and it didn't help, but just something to consider. Oops, sorry about that. Back to that answer there. Alright, so that'll do it for section 8.2.